Okay, so this one here, you move x to the other side, it becomes negative x plus 6. Then you divide by 3 and get negative 1 divided by 3x plus 2. Okay. Next one, you can move the 30 over. So we get 5x minus 30 equals negative 15y. Then divide by negative 15, and you're going to get positive 5 divided by negative 15, and then negative 30 divided by negative 15 is what? Plus 2. So totally simplified then, this would be negative 1/3 x plus 2 equals y. And you're probably going to rewrite that with y first, so it's more easier to look at. So what have we got here? The exact same equations, okay? How would you go from this equation to the other equation? What would you do to the first equation to give you the second one? How would you get your x's to be the same? Yeah, if you multiplied everything by 5, so you put big brackets around it and went times 5, you're going to get that second equation. Equations are kind of like fractions, equivalent fractions, right? With the equivalent fraction idea, if you have 2 over 5 and you times them both by 3, you're going to get 6 over 15. These are equivalent. Because you multiplied all parts by the same number, you're going to get equivalent systems, okay, or equivalent equations. So what we're dealing with here is we're dealing with a different form of an equation, but it's still the same value, okay? So what do you notice is that they are the same equation. Oops, having a writing problem this morning. Same equation. One is reduced. Okay, one is reduced, but they are equivalent, which basically means equal. So what we're going to use is this idea, and then we can eliminate equations by adding or subtracting. All right, so that's what elimination is all about. Now, with elimination, other teachers, they say, oh, one's adding and this is subtracting. Even your worksheet is going to have them separate, but you don't need to be. You don't need to be. You can do elimination on whichever way you want, adding or subtracting. So let's look into it a little bit. So our goal is to eliminate one of the variables. Okay, and we're going to eliminate by adding or subtracting 2 equations in order to solve for the remaining variable. Okay, so we're going to rewrite using an equivalent form. Here we have x and y. What we have to do is get that we can eliminate right now, right? Which variable could we eliminate? We could eliminate the y. Why? Because they have the same coefficient. Same or opposite coefficient. So this is a +1 and this is a -1. Why? Those are the same numbers, 1 and 1. It's wonderful. One's positive, one's negative. Okay? So the question is, should we add or subtract to get them to eliminate? Well, if they're the same, right? If they're the same, then we should subtract. Are our numbers the same? No, one's positive, one's negative. If they're opposites, then we should add. And we have opposites. So what we do the old vertical adding and subtracting. So we're going to go vertical. Okay. So what's x plus 2x? 3x. What's positive 1 minus 1? 0y. But guess what? Don't write it then. Okay? The y's cancel out. They're gone. They've been eliminated. Hence, we call this elimination. Okay? Now, what's 2 plus 7? 9. There we go. So now we can solve for x. Divide both sides by 3. We get x equals 3. All right? There we go. So let's go. Now what you can do is you can do elimination again, or we could just substitute in and solve. Let's just substitute in and solve. So we get x plus y equals 2. That's the easiest one to work with. So you substitute it in. 3 plus y equals 2. Y equals negative 1. Easy peasy lemon squeezy. Any questions? Okay, let's look at the next one then. So we have 7x plus y, 3x plus y. Which one should we eliminate? Which one? Well, sorry, which letter, x or y? X or y? Because I asked, x or y? Sure, y, let's do it. You guys aren't even paying attention, man. Holy smokes, you didn't even acknowledge it. It's a horrible pun. You guys just like, ugh. Okay, so we want to eliminate our y. Should we add or subtract? Good, because if you added then you would get a 2y, and that's not elimination at all. Now we got to be super careful with subtraction, so don't go ahead and do this. Okay, what's 7 minus 3? 4x. You're not going to mess that part up. But what about this one here? Y plus y minus y? There's 0. Okay. Now what about the last one? 15 and 3? 12. But you'll notice you have to remember you're subtracting. Students that mess this up do not look at the front and realize they're subtracting. And when you get double signs, things get weird. Always understand that you're subtracting. Okay? And so what does x equal? X equals 3. Okay? So then we can go and substitute in. Which equation you want to substitute? You pick off the bro. Off the bottom. Sounds good. So 3x plus y equals 3. Go ahead and solve that. Okay, so what's the solution to the system? Nope. I didn't do it up above because I assumed we knew, but I don't think we do know. What's the solution? Comma, 3, sorry, bracket, 3, comma, negative 6, bracket. Okay. So up above, we should formalize that as well. It's bracket 3, comma, negative 1, bracket. Okay. So you got to make sure you also identify what the solution is. What some students do, which I kind of like, is they put a box around it so it's easy to see. Okay, makes it nice for Mr. Barker. All right, and usually they write it on the side. So they would take this solution right here, and they would put it over here. Easy for Mr. Barker to mark, and he usually gives you full marks then. All right, the next one. The next one's not so easy, right? Our x's aren't ready to eliminate because their coefficients are different, and the y's are not ready to eliminate because their coefficients are different. So my question to you is, what can we do to the top equation to get the x's ready to eliminate? Multiply by 3. So let's go ahead and do that. Top one by 3, and we get 3x, what? Minus 6y equals what? 21. So remember, you got to multiply into all parts of the equation in order to keep it equal. The bottom one, do we have to do anything? No, so it stays exactly the same. And now is where you got to think a little bit. Should you add or subtract to eliminate? In this case, you should subtract. Okay? And now you got to do the hardest math you've done all year. What's the answer to the y's? Now remember, it's negative 6y minus positive 4y. What does that equal? Negative 10y. Okay.
So in unit 1, we have the x is equal to 1?
Well, no, because we're going to eliminate the y's coming up. You want to get one of them equivalent. Either get your x's the same or your y's the same. Okay? All right. So what does y equal? 2. Negative 2. Negative 2. Okay? Good. So now what we're going to do is we're going to do elimination of the y's. Okay? What could you do to eliminate the y's? What could you do to the top one? What would you multiply by? 2. And so you would get what? (2x) minus 4y. And that's why we chose 2, was to get them the same. Now, they're not really the same, are they? Right? They're opposites. They're both 4, but one's positive, one's negative. When they're the opposites, should we add or subtract to eliminate? Well, let's just say we chose subtraction. That would be negative 4y minus positive 4y, which equals negative 8y. So do we want to do a subtraction? No. That's why you got to be very careful with the subtraction part, okay? And you're going to have to do it. I'm going to force you to. You don't want to subtract. You want to add. Okay, go ahead. Add. The y's cancel out. Well, that's pretty smooth, isn't it? Love it. What's the answer then? 3 comma negative 2 with brackets right off the bro. And in a box, so it's easy for Mr. Barker to see. Okay. So this is double elimination. First we eliminated our x's, and then down below we eliminated our y's. And then we solve for each one. Okay. Now, if you want to eliminate 1, you can use what we did up in example 2 and 1, right? You can do the substitute in and find the value. But I know for a fact, I'm going to give you some, when you get fractions, you definitely want to do double elimination. And I'm going to give you some on the test just to see if you can do them. Okay? All right, turn it over. Yes, this would be an example of double elimination because you eliminate your x's, then you eliminate your y's. Yeah, you can write that down if you want double elimination. Just turn it off. Okay. Good. All right, so let's practice our double elimination. This one's going to be a little bit harder because we don't have to just multiply one equation. We got to multiply the other one as well. So what do you want to eliminate? Trevor, do you want to eliminate your x's or your y's first? Awesome. So what would be the common number for x? We have 2 and a 5. 10, right? That would be the lowest common multiple between 2 and 5, 10. So what would you multiply the top equation by? 5. So times this by 5, the whole thing, okay? So you can use the arrow. Some people just use the brackets and then they use the arrow. So they show it like this. And then you would get 10x plus 15y equals what? 40. Okay. What would you multiply the bottom equation by? 2. Oh, you guys are good at this. Just like fractions, aren't they? Add or subtract. Yeah, because the x's are exactly the same, you have to subtract. Okay? Now be careful. I'm going to give you a chance to do it. Go for it. So me, I'm a little bit slow this morning. Well, all mornings. So I'm going to use my calculator. 15 minus 8, and it's negative 8. And I get 23. So if you're uncertain with this stuff, go ahead, use your calculator, double check. Right? And then I got 40 minus 12, and it's negative 12. And so I get 52. Now this looks like a pretty nasty answer. But I'm going to double check. 52 divided by 23. Ooh, that's nasty. So I'm going to leave it as a fraction. 52 over 23. Okay. 23 is prime, so it's in lowest terms. Okay. How am I going to find my x value? Yeah, this is an example where I force you to do double elimination or a whole lot of really tough pain-in-the-butt math. Okay, so let's go and do some double elimination then. How can we eliminate our y's? What would I multiply the top one by? Well, you gotta look at your y's. What would be the LCM between 3 and 4? 12, right? We want to get 12y, so to do that, the top one we multiply by 4. People have been saying that, I know. And what we multiply the bottom one by? Yeah, 3. So again, our goal is to get 12y. And usually we're going to cook these up so that they're doable. Okay, they're not going to be crazy hard numbers. Okay, so we had 15x minus 12y equals negative 18. Now, should we add or subtract? Because the 12s are opposites, one's positive, one's negative, we should absolutely add. Go ahead, do the math, find your y value. So you get another nasty fraction, okay? Don't forget, you got to show me your solution properly. So nasty fraction for your x value and nasty fraction for your y value. And since you want to make sure it's easy for me to mark, because then I mark so much nicer, you put it in a little bit of a box, okay? Easy peasy, lemon squeezy. All right. Any questions? Okay. So this next one here, number 5, this will be the hardest of the hard. So you have fractions to start with. Now we don't want to work with our fractions, do we? No, we never do. We want to change them into another equivalent equation. So what would I multiply the top equation by? 2 and a 4, so I multiply it by 4. Okay, so 4 would be the LCM. So multiply it out. We won't solve this one the whole way, okay? We'll just do this little trick, and I think we're good. So we get 3x minus y equals negative 16. Hands up if you got that. Okay. What do you multiply the bottom one by?
6.
Chase, what do you think? 3 and 2? 6. Okay, so multiply it by 6. Making sure we're actively thinking, please, okay? Okay, so figure out your answer right here. This one's going to be a little bit more challenging. And Mr. Barker screwed something up, didn't he? What did I screw up? This shouldn't be 3x, because I multiplied by a 4. This should be 6x. Okay. Yeah, should be 6x. Okay. So when you times it by 4, these cancel to a 2. So I still have 2 times 3 multiplication to do. Okay. All right. There we go. 2x plus 3y equals 48. Any questions about that? So let's get our y's the same. What are we going to do to eliminate our y's? Multiply the top equation by 3. Okay. So times it by 3. The bottom one you can just rewrite and move over. You always want to line up when you eliminate because it makes it easier to track your eliminations. Ooh, that's a tough one. 16 times 3. Oh. All right. Add or subtract? Add, right? So they're opposites, so we want to add them, and they'll get to u to 0, and they'll be gone. Now, this is a totally weird question here. So we get 20x equals what? 0. So what does x equal? 0 over 20, which equals, double check on your calculator. What if it's undefined? You don't know until you check. Okay, 0. All right. So that goes, right, that's 0. That's fine. That's a legit number. Let's substitute that in and find our y value. Where do you want to substitute it? Right. This 0, you could substitute it in here, or you could substitute it into that one. I would try to avoid in here because that's going to be a painful and nasty. Okay. So let's substitute into the first one. So 6 times 0 minus y equals negative 16. So take the time to realize that's negative y. Do we want to know what negative y is? No, we want to know what positive y is. So what's the solution? 0, comma, positive 16. And put it in a square. Okay. Okay, so that's the full meal deal. That's the hardest one you're going to see, to get rid of the fractions. Now, you could do double elimination there. You totally could. But you know what? We've already done that once, so I don't feel like showing it twice. Okay. Any questions? Your worksheets are going to be more of this variety. Okay. So you're going to get some of these ones where you have to multiply both equations to get a common multiple. But a lot of your easier work is going to be like this example. We'll just multiply one equation to get numbers that you can eliminate. Okay. Ignore the instructions on the worksheet with regards to adding or subtracting. You figure out what you want to do. You can add or subtract, just eliminate. I'd rather you think about it and do whichever one you feel like doing, okay? But make sure you do both, right? Make sure you do both, get the practice in. Okay, go, begin, good luck. There's 2 worksheets. They're later in the booklet.